Assalamu alaikum. Okay, we will continue by discuss the heat engine and refrigerators. Okay, in last lecture we defined the heat engine المحرك الحراري. The heat engine هو عبارة عن a device that transform heat partially into work. من اسمه heat engine محرك الحراري. إذا هو راح يحول الحرارة لورك اللي هي ميكانيكال انرجي، لأنه احنا بنعرف الورك إما إنها بتكون على شكل ميكانيكال انرجي أو بدها تكون potential انرجي، لكن احنا in this case هي عبارة عن mechanical energy by a working substance undergoing a cyclic process. إذا بتكون في cycle، والcycle process عرفناها إذا start from state and end in the same state, or start from initial state and back to the initial state again after passes different process. إذا this is the schematic drawing of the steam engine المحرك البخاري. عندنا water. الووتر نتيجة الهيت بيتحول لبخار. هذا البخار حوالي several hundred atmosphere and water vaporized at about 500 Celsius، حوالي 500 درجة مئوية. Okay, in this case we have the engine. إذا تحولت من heat إلى إيش؟ إلى work. هذا الورك نتيجة الورك بيتحرك إيش؟ المحرك الإنجن. أوكي. إذا كمان بالمحاضرة السابقة ناقشنا عدة statements للسكند law, and these statements is very important in the second law of thermodynamics. So we have or defined that, we found that the entropy of the system never decreases. إذا الانتروبي ما بتتناقص نهائيا. إذا the change of the entropy it's always greater than zero. اثنين, you cannot change heat energy into work with 100 efficiency. ما في عنا efficiency it's 100. That is, there are no perfect engine. ما في محرك perfect نهائيا. This is Kelvin version. إذا هذا Kelvin statements about the talk about the efficiency and the perfect engine. Okay. Another important things also, you cannot transfer heat energy from a low temperature reservoir to a higher temperature reservoir without doing work. So we need work to transform heat from low temperature to higher temperature. That is, and there are no perfect refrigerators. Okay. إذا برضو نفس الشيء ما في عنا perfect ثلاجات perfect. This is a classless version or classless statement. Okay. One of the important thing for the process or cycle process is Carnot engine. إذا محرك كارنوت or سادي كارنوت, he is a Frenchman سنة 1824. إيش بتحكي كارنوت سايكل؟ إيش حكى؟ حكى إنه الهيت engine with a maximum possible efficiency consists with the second law. كمان all thermal process in the cycle must be reversible. All heat transfer must occur isothermally because conversion of work into heat is irreversible. إذا عملية تحول الورك من الهيت هي عملية irreversible. Also, when the temperature of the working substance change, there must be zero heat exchange, and this is a adiabatic process. إذا Carnot cycle consists of two reversible isotherm and two reversible adiabatic. Then we have, in this case, we have hot reversible. We assume that all thermodynamic processes in the Carnot cycle are reversible. Then we have this hot reservoir, temperature at high temperature, and we have QH. This is the engine المحرك. إذا from hot reservoir TH goes to engine, then we are doing work, so also we have QC over cold reservoir. إذا QH heat, this is QH, it's taken from heat source. إذا we have the source QH come out from the heat source. Then we have also QC. QC, this is heat removed to heat sink. Okay, and we have the work done, and we have temperature of heat source, and also we have temperature of heat sink. Okay, in the Carnot cycle, we have four processes. For Carnot cycle, we have two adiabatic and two isothermal. So the first is we have isothermal expansion. Then we have adiabatic expansion and isothermal compression. Also adiabatic compression. Then we have two isothermal process. One is expansion, the second is compression. So, and also we have two adiabatic process. One adiabatic expansion, the other is adiabatic compression. Then we have this four process, and this is occur in the in the car. So efficiency of car engine أو في المحرك لا engine. In practice, the Carnot cycle cannot be used a heat engine because the slopes of the adiabatic and isothermal lines are very similar, and the network output or area enclosed by BB diagram is too small to overcome حتى إيش تعمل لنا overcome the friction and other losses at real engine. So efficiency of Carnot engine, maximum possible efficiency for heat engine operating between TC and TH. Okay, so the purpose of the engine is to transfer as much of extract heat QH into work as possible. We define thermal efficiency as هي عبارة عن ال energy you get على ال energy you pay for. So the efficiency هي عبارة عن ال work مقسومة على QH. Then we know the work equal QH minus QC, and if you substitute this instead of the work, then efficiency تساوي work over QH وتساوي 1 minus QC over QH وتساوي أيضا 1 minus TC على TH. إذا لو أعطانا example QC و QH بنقدر نوجد الافشنسي. لو كانت معروفة temperature TC و TH بنقدر كمان نوجد الافشنسي. أوكي. إذا derivation of a maximum efficiency for heat engine. حكينا إنه Carnot cycle is reversible cycle between two heat reservoir. Okay, isothermal process. In isothermal process QH بتساوي the work done by gas. الانتجرال from V1 to V2 BdV وتساوي NRTH في لأن ال V2 على V1 and QC working on gas تساوي minus integral from V3 ل V4 okay from V3 ل V4 وتساوي NRTC fill in ال V3 على V4 إذا we have here from V1 to V2 is TH. We have here is TH and we have here TC. Okay, here is TH and here is TC. In a diabetic process, if we back to previous lecture, so we have this definition TH. Now we have TH V2 to gamma to power gamma minus 1 V to gamma minus 1, and we have also TH في V1 to gamma minus 1 تساوي TC في V4 to gamma minus 1. هذا يؤدي إلى أنه V2 على V1 تساوي V3 على V4. إذا QC على QH تساوي TC over TH. This is the efficiency equal 1 minus QC over QH وتساوي أيضا 1 minus TC over TH. إذا from 1 to 2 this process is cold, okay, and from 3 to 4 the process is hot. And we can see this the efficiency, this curve between the efficiency. Okay, the maximum efficiency of course is 1, and we said before that it's never can be found the 100%. So you can see the curve. So it's less than point. It's less than 90%. Even we have here the temperature from 200 to 2000 Celsius. Okay. إذن perfect engine, no extra entropy generated. The condition of continuous operation, the entropy, the change of entropy at high temperature equal the entropy, the change of entropy at cold, hot, cold, وتساوي QH over TH وتساوي QC على TC. هذا يؤدي إلى أنه QC تساوي TC على TH مضروبة في QH. Then we have hot reservoir at high temperature and we have cold reservoir at cold temperature. So here is delta S hot تساوي QH على TH. So we have also that the change of the entropy called تساوي QS على TC. Then we have this the entropy, and then we have heat and goes by work. Okay, then it's done by the work, on the work, or by the work. So the work generated during one cycle of reversible process equal the work QH minus QC. And if you substitute instead of QH and QC, which equal TH minus TC على TH مضروب في QH. إذا Carnot efficiency, the highest possible value of the energy conversion efficiency. efficiency of max تساوي الwork over QH وتساوي 1 minus TC over TH, and it's always less than 1. This is the absolute maximum efficiency of heat engine. Okay. Then this is the end of this lecture, and we will continue next lecture. Thank you for your attention.